Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to my presentation video. So this is my first presentation video, and I am going to talk the example regarding to the Fourier series and chapter 1. Okay, if you look at the example, then you can see delta u by delta t equal k delta square u delta x square, then u x0 equal fx, then delta u by delta x 0 to equal 0, delta u by delta x l t equal 0. Okay, so let's make it in differentiation. D by dt equal vx gt, so we use v and g, so equal k delta square delta x square vx and gt. Okay, then if you make it, then we can get 1 by k g by t delta by delta t g by t equal 1 by vx minus delta square delta x square vx equal minus lambda. Okay, then we can make this make it two part. We can separate lambda for both, then 1 by kg divide 1 divided by kg t delta delta t gt equal minus lambda, and another one is 1 divided by vx delta square delta x square vx equal minus lambda. Okay, this is the full differentiation, and so you can see the first one is 1 by kg by t, then delta delta t gt minus lambda. So if we make it, then we can get the final result, delta by delta t gt equal minus lambda k and gt, and the right side we get delta square delta x square vx equal minus lambda vx. Okay, so this part is to find the r. So delta square by v by x delta x square plus delta dot vx equals 0. So delta square v by delta x square plus delta v equals 0. R square plus lambda equals 0. So r square equal to minus lambda, so r equal to plus minus lambda square. Okay, so now we have to apply the boundary condition. So if we apply the boundary condition, then we get delta u by delta x 0 t equal 0, and delta u by delta x l t equal 0. Then we we put in the equation. So u 0 t equal v and g, so v is 0 and gt equal 0. So u is u l dot t equal vl and gl equal 0. Okay, this here is a more simplification, and so u 0 t equal v naught v 0 and z t equal 0, and we can see the right side v naught equal 0, v 0 equal 0 and z 0 also 0, and so another one vl equal 0 and z t equal 0. So u l t equal vl and g t equal 0. So gt equal not gt not equal 0, and gt cannot be 0, so we cannot accept if gt equal 0. So v naught equal v0 equal v0 equal 0 and vl equal to 0. This is the solution for boundary condition. Next, okay, so come back to the r. So r equal plus minus root over minus lambda, and there are three situations for lambda. So lambda equal greater than 0, lambda equal 0, and lambda less than 0. So let's apply the first one. If the lambda is greater than 0, then r equal plus minus minus 2. If because the lambda equal minus because the lambda equals 2. So Vx equals C1 sin root over lambda x plus C2 cos root over lambda y. So we can cut sine to cos and cos to sines according to the equation. Okay, so let's differentiate. If you differentiate, then dv by dx equal to minus C1 sin root over lambda x dot lambda plus C2 cos root over lambda x dot lambda. So we get lambda root over lambda. Sorry, before I tell lambda square, so it should be root over lambda. Sorry, root over lambda minus C1 sin root over lambda x plus C2 and cos root over lambda x. Okay, dv by dx cx equal 0. So then we get root over lambda minus C1 sin root over lambda 0 x plus C2 cos root over lambda. So sin 0 equals 0 and cos 0 equal 0. Okay, so if the C2 equals 0, if you look at the below part of this screen, then you can see C2 equals 0, then dv by delta x equal L equals 0. So root over lambda minus sine root over lambda L plus C2 cos root over lambda L equals 0. So finally we get root over lambda L equal to n pi. So root over 2 minus n pi. So the Vx equals C1 cos, this is the according to previous equation. So C1 cos root over lambda x plus C2 sin root over lambda x, C1 cos root over n lambda divided by 2 whole square into x plus C2 sin whole square n lambda n pi divided by L the square by x. Then finally we get, because we know C2 equals 0, so Vx equal, we get C1 cos n pi divided by L and x. So this is the solution for if the lambda is greater than 0. So if lambda is equal 0, then how? So r equal plus minus minus 0 whole square. So r equals 0, Vx equals C1 plus C2x. So we know C2 is 0 equals 0 and C2 equal 0. So finally we get Vx equal to C1. So Vx equal to 1 because C1 is constant. Okay, so if the lambda equal lambda is less than 0, then lambda equal minus 2. So r equal plus minus root over minus 2. So r equal plus minus root over 2. So r is greater than 0. So Vx equal to C1 e power root over minus lambda x plus C2 e power minus root over lambda x. So according to the boundary condition, then we get C1 minus C2 equals 0 1, and so C1 equal C2. So okay, if then dv by dx x equal L equals 0. So then if we do this, then we get C1 e power of root over minus lambda L equal C1 e power of root over minus lambda L, and finally we get, because e power 0 equal 1, so we get finally gt equal to C e power minus lambda t k t, because lambda is greater than 0 and lambda equal to 0, and Vx lambda Vx does not exist because lambda cannot be less than 0, or means lambda less than 0 doesn't exist. Okay, if we put this one in our there is two equation, you can see number 1 and number 2. So number 1 is lambda is greater than 0, and second is lambda equal 0. So if we replace lambda to the equation, then we get gt equal e power of minus k lambda t equal e power of minus k n pi by L square. So if now we express the solution, then we get u xt. Then so we can use equation 1. Okay, there are two equations, so we can only equation 1 when n equal 1 2 3 4 5 6 infinitive, and we can use the equation 2 when n equal 0. So so we can get introduce on general constant. Okay, so before introduce on general constant, then we can see the cos n pi x by L dot e minus k n pi divided by L square plus so if we introduce on general constant,